Hello boys and girls, today you're going to work on 7.13, the last assignment in this unit before you start working on the assessment, and the essential question for today is, how do you identify relationships between patterns? So let's warm up a little bit. The previous two lessons, you were working with one rule and trying to figure out using a graph and using a table and using a formula or using some sort of equation the answers to the questions. In today's lesson, you're going to see a little bit of a different look on it, and the reason being is because now we're giving you an in and out, same as usual, but now we're giving you a rule for each of those in and outs. So for this first example here for Class A, I'm giving you a rule of 1 and a rule for 2. And what I want you to do is I want you to come up with what's going to come next in this here, here, and here, for both the in and out category. So stop the video, grab a piece of scrap paper, and see what you can come up with based upon these two rules here. So if I know my rule for the in is going to be +1, I'm going to take that 1 that's already been given to us, and I'm going to add 1 more to it and give me a 2 here. And I'm going to add 1 more to that one and give me a 3, and add 1 more to the 3 to give me a 4. So that's no problem. In the out category, I have a 2 in that column, so I'm going to add 2 because that's what it tells me to do. So I'm going to get a 4 here. I'm going to have a 6 down here, and down in this last column I'm going to have an 8. So whatever that rule is, they're always going to give you at least one number in both the in and the out category, and then based upon that you just keep following that rule and adding more, multiplying more, dividing more, subtracting more. So here's a second example, and this one we're looking at a Class B, and their rule is +1 in the in category and +2 in the out category, but notice that their number changed a little bit for where they started. So I'd like for you to pause the video in a second and give me the next 3 numbers for these 2 columns as well. So go ahead and pause the video now. Okay, so my rule in the in category is still +1. So that means that this is still going to be 2 and 3 and 4. And in my out, the number is starting at 102, but I'm still just going to add. So I'm going to add 104, 106, and 108 because my rule here says to add 2. So you're probably asking yourself at this point, what's the Class A and the Class B have to do with this problem? So if we think about a real-life situation for these types of tables, if we look at Class A, we're going to pretend that the in category is the amount of students that are going on the trip to a museum. And so for 1 student, it's going to cost $2. For 2 students, it's going to cost $4. 3 students, $6, and so on and so forth. And we can keep going until we have that total amount of students. For Class B, they're going to go to this museum in a little bit of a different way, in that they're going to go with a tour guide. And the tour guide's going to cost them $100. So same price for the tickets, but they're going to be adding that $100 for the tour guide, so they might get a little bit more out of it. It's not going to be self-guided. So the in category still stays the same, 1, 2, 3, 4, but now they're going to add $100 to that fee one extra time. So for 1 student, it's going to cost $102, 2 students $104, and then so on and so forth. So based upon all this information, I can basically give you a little bit of a formula here, and the number of students going on the trip, so number of students on trip times 2 is going to equal the total cost. This formula is going to go over here, and the only difference for this next one is that we're going to add that additional $100. So the prices are pretty much going to be the same for each of the different classes, except Class B is going to have $100 more for each of the students. So if I look here and I look at $4, or 4 students, their cost up here for Class A is $8. Down here for B, because they added that tour guide, is $108. For 1 student, it's $102 with the tour guide. Without it, it's $2. With all of this being said, the formula down here that I've typed up, number of students on the trip times 2, because that's the cost of each of the tickets, and we're going to add that $100 for the tour guide, is going to equal our total cost. So this is going to incorporate a little bit more of a formula that's a little bit different than the top one that I had written. So we're going to do times number of students times 2 plus 100 to equal the total cost. Let's take a second and remind ourselves a little bit about formulas. Displayed in front of you are two formulas that you worked with earlier in the year in 5th grade. The first one is area of any shape, and that's equal to length times width. And the other formula that you worked with that you can see displayed here is volume, which is equal to length times width times height. So what's that have to do with anything that we were working with here in the warm-up? Let's take a look. Here are two examples, and I'm going to go through the first one with you. I want to know the cost of tickets for Class A compared to Class B if 17 students are going on the trip. So for Class A, we're going to do 17 times 2, which equals 34. And if you remember from the previous example, Class B is just going to be simply 17 times 2 plus 100, which is equal to 134 students. So the only difference here is this plus 100 because of that tour guide. So take a minute now, and on that scrap piece of paper you've been using, try and figure out how much it would cost for 25 students to go on the trip with Class A and Class B. Now that you've completed the work, the first one here we have is 25 times 2 for the cost of the tickets, which equals 50 for Class A, so it cost them $50. And for Class B, it's 25 times 2 plus 100, which is going to equal $150. So the corresponding difference there is that $100 difference between Class A and Class B because of the tour guide. Let's take a look at one more example. Our last example on the scrap piece of paper that I want you to complete is 83 students are going on the trip. So figure out 83 students, $2 each for A and then for B. When you're finished, play the video back again and see if you got the same answer. So we have 83 students, and they each cost $2 to go on the trip. And down here we have 83 students times the 2. But we've got to remember we've got to add that 100 for that tour guide. Oops, I forgot to multiply the 2 there. So now we have to do the math for those two. That'll cost Group A $166, which means that because Group B also has that tour guide, it's going to cost them that extra $100, so it's going to be $266. Here's another table that has two headings, and the rule for the inside is +1, and the rule for the out is +10. And this has something to do with a natural phenomenon that you're going to be reading about shortly. What I'd like for you to do on that scrap piece of paper one more time is I want you to tell me, based upon these rules and what we've learned so far, what would go here in this column and row, this column and row, and this column and row. So pause the video at this time and go ahead and answer those 3 columns for me. So let's take a look at this. If my rule in the left-hand side for the in column is +1, that would make this next row 3, the following 4, and the last 5. And over in the out, if it's +10, we can count by tens. We have 60, 70, and 80. Now that we've completed this next table, I'd like for you to turn to page 272 in your math journal, and you're going to read about Old Faithful. That's going to be at the top of the page, so go ahead and take a second and read about Old Faithful. So here, hopefully you've read Old Faithful here in the top of page 272, and I want you to pay close attention to the formula here that I'm highlighting at this time. And this formula says the wait time is equal to 10 times the length of the last eruption in minutes plus 30 minutes. So we're going to use this table down here to figure that out, and then we're going to do what we did in previous lessons. We're going to come up with some ordered pairs over here. And then finally what we're going to do is we're going to graph it in this final little section here. So let's go ahead and let's fill out this table first. So The left-hand column, or minutes, of the previous eruption has been done for us, and the wait time for the next eruption in minutes is what we need to fill out. And based upon that formula that we highlighted, we have to multiply or add 10 to the last eruption. So we have 40 there. That would make this here 50, adding 10. Add 10 more and we have 60. Add 10 more and we have 70. 10 more and we have 80. Add 10 more and we have 90. Now, we're going to need to stop for a second because our next time in minutes on the left-hand side is 2.5 minutes. So we have to think for a second. What do we have back here? At 50, at 2 minutes, we had 50 minutes. So we need to add half of that extra. So actually, it's going to come out to be 55 because we want to take half of it. And this last one here is 35. So if we look up top here at 40, that should be able to tell us that that's probably going to be a half a minute over here in this column. So this is going to be actually 1/2 of a minute. So now what we have is we have a bunch of ordered pairs over here, and they did the first one for us. You notice that this one has been done for us, 1,40. So we have to go through and we have to do the rest of the column. You can take a second now and do that. Okay, so the last step on this page, or for problem number 3, is to plot each point on the grid. Use a straight edge to connect the points. And I know you've done that in the previous 2 lessons, so we're going to go ahead and take a second and do that right now. Pause the video. Okay, boys and girls, here is the line that I have now plotted using those ordered pairs. And you can see that my line starts all the way there at the half a minute line and goes up to the 35. And then my last point is at 6 minutes. And the wait time is going to be all the way up top at 90. And notice that my line continues continuously because we could add more data to that table in the end. So now what you have to do is you have to answer the last question at the bottom, number 4, and it says it is 8:30 a.m. and the Old Faithful has just finished a 4-minute eruption. About what time will the next eruption occur? So make sure you can use the chart, you can use the table to figure that question out. Explain how you found your answer. You've got to tell us which way did you use it. Which piece of data did you use? Did you use the table? Did you use the ordered pair? Or did you use the line graph? And go ahead and answer that question now for us at the bottom of page 272. To finish up this lesson today, you need to do math boxes on page 273. You need to grab the home link on 7.13, which is out in the bin, and you need to make sure that you are working really, really hard and watching this entire video, Riley.